Hey guys, welcome back to AlgoYogi. We are doing stack series and our next problem in the list is minimum add to make parenthesis valid. Let's go to LeetCode and give this problem a read. So a parenthesis string is valid if and only if these three conditions basically are followed. If it is an empty string, it's a valid parenthesis. It can be written as AB, and within these two other basically parentheses, and A concatenated with B, where A and B are both valid strings, and then it can be written as A between the strings, and A is a valid string. By the way, all these strings that they're talking about, they all involve just these two brackets, opening and closing brackets. So, and for example, they're saying that, for example, S is right here. There is one opening bracket, closing bracket, and there are two opening brackets that do not match with anything. So you can insert an opening parenthesis to B to make it basically this, or a closing parenthesis to make it this. So they're just talking about like insertion here, like you can insert either an opening or a closing right here. So you just insert one more closing, make it more imbalanced, and if you insert an opening in the beginning, you make it little balanced, more balanced. So we are given a string. We need to return minimum number of moves required to make S valid or balanced, perfectly balanced, valid string. So let's see what we really need to do. We are given this string, and the valid strings are basically either this, or basically there is another string here where this could be a valid parenthesis, something like this, or this, like that, or maybe it could be even this. So these are all valid parentheses. So this is valid, then also A, B, these are two valid. These could be anything from here, but they are just concatenated together. Okay, so now we understand that what are these valid parentheses. So S is given to us. S is not valid. We have to make it valid. And how do we do it? By inserting minimum number of required these parentheses. So return the minimum number of moves required to make S valid. So how do we do that? So I think it's all about finding that imbalanced number of parentheses and return that number. And that you can do basically by making use of stack. Let's say if we use a stack here, so you can see directly, like in this example, this particular open parenthesis matching with this closing parenthesis, this is good, but then there is this one closing parenthesis that doesn't have a matching opening parenthesis. So we will return the answer 1, because after making this change, one insertion right here, either here or here, wherever you guys think appropriate for you. So if we make an insertion over here, then this becomes a string which is 2 opening bracket and 2 closing bracket, right? So we will return our answer 1, because we needed one operation to insert one opening bracket to make it a valid string. All right, so I guess in order to find this imbalance, so let's say if we are given this string, oh my god, let me just call it this, and these are like 3 parentheses. First of all, they have to be even number, but let's make use of stack. We will have our stack, and inside our stack we will push everything until we see a closing bracket. So if we see an opening bracket, we will push it onto the stack. That's the, oh my god, I just threw the pen, it slipped away. So we will append the opening bracket, and then we see a closing bracket. So what we want to do is here is we want to check if stack, if let's say, so I'll have, let's say, some variable called count will track how many operations we need. So in this case, I'll just say I will have this condition where I'll say if either not stack, that means, and that will, I will check, let's say for for C in my string S, if this C is equals to a closing bracket, that means I should have on top of my stack an opening bracket to match it. So but if either not stack or stack stop right here, stack stop is not equals to an opening bracket, that means I need to increment my count. So count plus, increment your count, because then we actually need one insertion right before this or anywhere somewhere to basically create this matching pair opening bracket for this closing bracket, right? Then otherwise else case would be here, that you are seeing a matching basically a stack exists and the top also matches with opening with this closing. So you'll just basically stack.pop, right? You're popping immediately whatever was here. So you when we were right here, so I see the top of the stack has an opening bracket, so that means I'm right here and I'm popping this out. So I'll pop this out. Then I go next, I see like a closing bracket, then I'll come here, stack, there is nothing in the stack, so I'll increment count becomes 1, and that's what I will return in the end. But there is one more thing, I will be returning count plus length of my stack, and let me tell you why. The reason is, what if, and before we do that, let me basically just shrink our code right here, and let's say my example here was something like S was equals to just all opening brackets and one closing bracket. Okay, so in this case what will happen is we will have a stack, and then we see opening bracket, we append, we see opening bracket, we append. And remember, by the way, there is one more else case right here, and I guess you will know that else case is just appending everything to your stack. Else case is like stack dot append the C. Okay, you write right here before the return, and I can just write it. So right here, else stack dot append C, and then return stack length plus count. Okay, this is it. So I appended this, then I see another opening bracket, then I see a closing bracket. I'll come here, stack is not empty, so I'll just pop it. So I'm popping one of this. Now my count is still 0 because I have not incremented anything in my 0 for this example, but my stack is still non-empty with two opening braces or two opening bracket, which definitely need two closing brackets. So we only considered the opening bracket. So I'll have here length of my stack plus count. So count here is 0, but stack length is 2. So I will return 2 here in this case because I'll need 2 more insertion to make it a valid string. Simple approach, and big of and time complexity solution, big of and space time complexity solution. But I'm definitely sure that you can get rid of the space by making use of some pointers where you just track. You basically what you're trying to do at the end of the day is just calculating the imbalance between the opening and closing brackets. Okay, so I just forgot to change this screen. Let's have it. But let's just, this is stack series, so let's just do it the stack way, but definitely keep experimenting, keep trying. So for C in S, if my C is equals to I'm seeing a closing bracket, that means if not stack or stack stop is not equals to opening bracket, that means there is an imbalance. So let's have a count 0, and then let's increment the count plus equals 1. But remember, here we will not be appending it, we just calculated that imbalance, we incremented our count. One more thing will be just if this case didn't exist, that means stacks has some value, and that is actually matching with this opening brackets, so closing brackets with an opening bracket. So we will just pop that out because we're done doing that. Like, there is a perfect valid opening bracket for a closing bracket. So I will just stack dot pop. I don't have to deal with this anymore. Then else case here was basically appending everything to stack. I mean, not everything, just the opening bracket. That's what it is for. Append the opening bracket. That's it. Finally, we can just return. We can just return. What do you return? You return the length of your stack plus your count. Okay, let's simple. Let's zoom out, run it on our examples. Awesome. Let's submit. So it's an easy problem. Should have been easy. Yeah, and it's like 100%. So I don't know, like, if this is a very efficient, clean code making use of stack. So let's write down the time complexity. Time complexity would be big of n, and space complexity is big of n as well. But I'm 100% sure there is this imbalance approach that we can explore later, but right now we're doing stack series, and this is also acceptable, 100% efficient solution. Okay, so let's go to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye bye.